So in today's video, we're going to be taking apart the Avalon Nano and replacing some of the thermal paste. This comes from the last video where we were looking at taking off some of our inefficient miners and just replacing the thermal paste on them. The Avalon was one of them. We also had a bitaxe Gamma, which is the AliExpress one. And then we had a bitaxe Supra, which was our first bitaxe, I believe. So we're looking to replace the thermal paste on all of them at some point and on the miners that are still on, but we'll have to take them off to do that. But today we're going to be replacing the thermal paste on the Avalon Nano. The main thing that we want to do is take off the screen firstly, take off the fans. I mean, the fans are attached to the screen, so it doesn't really matter. And then take off this first heatsink that you see here with the screws attached. So this is a very compact miner. You'll get to see all of the chips underneath. And we did this for the Zyber 8, so you can check out the Zyber 8 teardown as well if you want to. It's maybe 4 videos ago. But today we're going to be doing the Avalon Nano, checking to see all the chips underneath, the heatsink, and then we were going to replace the fans to knock the fans at some point. But you'll see kind of in the video why we can't really do that right now. So this is out of the case already. If you haven't seen the really old video, we did take this out of the case, trying to basically trick the heat sensors within it to give us a better hash rate, but that doesn't really work because of the firmware in the Avalon Nano. And Avalon are very kind of protective of the firmware, and they don't really want to open source it. Even on the computer when we are viewing it, there's not really much options in terms of what you can do. There's 3 options, which is the high, low, and medium mode. So that's all you get. So before we get into the video, I'd like to thank the sponsor of this video, Crypto Miner Bros. Since 2018, CryptoMinerBros.com has been the premier site for top-tier crypto mining hardware, earning the trust of miners across the globe. The prices displayed on their site cover shipping and DDP straight to your doorstep, ensuring no unexpected costs at checkout. They deliver to over 100 countries and even provide lower invoicing options to help you cut down on customs fees. Payment is a breeze with options like direct bank transfer or cryptocurrencies including Bitcoin, USDT, or Ethereum. With over 250 ASIC options, they stock some of the channel's favorites like the bitaxe Touch, and the Avalon Nano3S. Join tens of thousands of happy customers who rely on CryptoMinerBros.com for dependable hardware fulfillment, clear pricing, and a top-notch service. Check out CryptoMinerBros.com today, link in the description. Okay, so now we're back. The first step is to take off this LCD screen. So you just give it a bit of a pull and it comes off. So you can see underneath here, this is where the fans connect. So you have the USB port, which is here, and that's for the power into there. And then you have the fans that connect. So the reason that we wouldn't change to knock the fans is because I can't find the same attachment that you're seeing here for the Nocta fans. So if anyone can let me know, that'd be great. But we're just going to move this to the side here. And then we can focus on the actual Avalon Nano. So the good thing about Avalon Nano is that you don't really have to do much in terms of specialized screwdrivers. All it takes is kind of your standard screwdriver to actually undo all of these. So what I would do normally is just start on one of them and unscrew it a little bit. Because they're spring pinned into there, you would not want to bend the board. So you just take each one out individually by one tick, one tick, one tick, and then you keep going, and you can gradually move it up to 1, 2, or 3 turns, just so you're not bending the board underneath and not damaging anything, because these are very delicate in terms of the electronics underneath. So what we're going to do is we're going to unscrew all of that, and then we'll take the heatsink actually off on here. So we've unscrewed all of these. Let's try to get it back into frame. Unscrewed all of these, and now we can just move them to the side, and we can take the heatsink off. So here is what the Avalon Nano looks like underneath. So you have your chips, which are all across here. I don't know why they don't have 14 chips, but they only have 12 on here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. And that is just like a mirror image of this. I don't know why they don't have a chip here and they don't have a chip here. It would be good because you'd just get more hash rate and more heat maybe. But that's the thing about the Avalon Nano, it is made for heat. It's not necessarily made for you to overclock it on anything. There is some residue here, which I don't know what that is. Maybe it's a bit of just heat exposure. But you can kind of see on the heatsink right here that you have little spots where you can see the heat starting to degrade some of it, or just some thermal paste overlaying and coming out onto the heatsink. I don't know if this is copper or not, but these are clearly specialized heat sinks that were made especially for Avalon Nano, so I don't think there'll be an upgrade video of them anytime soon. So now that we've got this here, what we're going to do is we're going to clean the thermal paste off of the heatsink. As you can see, there's not really loads of thermal paste on there, so they're being very sparing with the thermal paste, which is good because you're probably getting a better connection, and this is probably manufactured at a higher quantity, so they know exactly how much they're putting on each one. But this is going to be a bit of a jerry-rig video, so it doesn't really matter. But we're going to clean each one individually, so I'm going to go with the heatsink first. I'm going to put that over there, and all we're going to do, like you saw with the Zyber 8 video, is we're just going to spray this with isopropyl alcohol and then rub it off with like some kitchen roll, basically, because it doesn't really need to be perfect, and then you can clean it up with a cotton bud. Now, a lot of people say they like to use microfiber. You can do that as well. I mean, it doesn't really matter that much in an overall scale. This is still going to run at a certain temperature, so it doesn't really matter for the Avalon Nano. But let's hit this with some isopropyl alcohol and then we'll get it actually cleaned up. So if you can see here, all we're going to do is spray it with some isopropyl, and then don't worry about it going on the side. It will eventually it will eventually come off. So if you can see this here, just take this and go in. So one thing about this is I'm noticing right now is this thermal paste is very much stuck on there. So maybe we'll have to cut until we've got it all off, because it looks like that's caked onto there because of the heat. So we'll come back when we've actually cleaned it all the way fully up, but that's the process that I would use. So I think that's about as good as we're going to get it. So pretty much all of the thermal paste is taken off. You can still see some of the markings from the thermal paste like heating up on the sides by here, but pretty much overall it was fairly easy. It was more like scraping off the thermal paste and not necessarily cleaning it off, because we basically scraped each one down. And that leads me to believe that when it comes to the chips, that thermal paste is going to be very hard to actually get off without really applying some pressure to the chips. But what we could do is we might let it soak. So we might let some of the thermal paste just kind of soak into the chips. But I'll give you a better view of what it looks like by here. But my best guess is that that thermal paste is quite stuck onto those chips, and it's probably going to be hard just to rub them off with some isopropyl alcohol. So we're going to probably spend a good half an hour trying to delicately take off this thermal paste. And it even seems that there is some sort of glue holding this heatsink in place, because I don't see any screws. So some thermal glue maybe that's kind of pressured down into this heatsink at the bottom. But I'm assuming that there's some sort of thermal paste on the bottom of that as well that we might actually need to go in and replace, because you can see there, I don't know if you can see that very well, but there's a little bit of glue or thermal paste on the side there. So we might have a look into that. But it doesn't look like, from what I can see, there's anything that you would be able to take this apart with or take the other heatsink off. But anyway, let's spend a little bit cleaning up some of the thermal paste on here, and then we'll get back when we've kind of got it down to a level that we like, mainly so we can see the number on the actual chip underneath. That's mainly what I go for, at least. So we'll get back when we've done that. So as you can see here, this is basically the best that we could get it up to. And it was quite a struggle to actually clean this. There could be a little bit more in terms of the, there's a little bit of specks of thermal paste sitting on these heat sinks. But overall, I think that this is a good enough job. All the chips look amazing. and there's no kind of defects in them. The one main thing that I am concerned about is the fact that the actual thermal paste was really caked on. So I think some people have been having problems where these shut down very quickly, maybe after 3 or 4 months. And I think it's actually to do with the thermal paste because it was caked onto the heatsink, and that was basically scraping it off. And then it was kind of caked onto here, and when we were kind of cleaning it out, we would get specks of like thermal paste, which is like this big or the size of the chip, that would just flake off, which probably means that a lot of people's are overheating in that regard. And you can even see that there's some thermal paste. I don't know if you can see that well on the camera, but into the divots on the side of the chips, there's still some thermal paste in there which we cannot get out. So this is my best try at doing the cleanup job, and there is some thermal paste on the sides here which we still need to go in and probably take out in the background before we actually add the thermal paste. But overall, it was not as hard as scraping off the thermal paste from here. We just kind of let a little bit of isopropyl alcohol kind of sit in there and kind of just dabbed it on to each one, let it kind of mix in with the thermal paste, and then went in and scrubbed it away. But even then, it was a bit flaky to actually get the thermal paste off. It wasn't, you know, like a bitaxe where once you've repasted it, you can actually just wipe it off, which is interesting to see. Obviously, these are operating at a higher temperature, so that's probably the reason that the thermal paste is not doing as well. I'd also like to know kind of what thermal paste everyone else is using, because with the bitaxe or bitaxe suppliers, I don't think it's actually listed what thermal paste they use. But it'd be good if these were listed with thermal paste that they use, even the bitaxes, NerdQXs, what thermal paste they actually come with, so you know to replace it with that thermal paste to get the exact same kind of hash rates. But with the Avalon Nano, it doesn't really matter. So we're actually going to add the thermal paste back on. We're going to do a final cleanup and then start adding the thermal paste to each chip. So again, like in the Zybet 8 video, we are going to be using the MX6. So I'm going to try to do this whilst we're actually filming it, but we are going for pretty much a rice. We're going for pretty much a rice grain, so maybe a little bit less than that, if you're seeing that on the camera. Don't know if it's focusing or not. But we're going to be doing that on every chip, and then we'll come back when that's actually fully done. So as you can see there, that's what we're going with. It's not really the best job or whatever. I tried to judge it and keep it equal. I have a feeling that this one's going to be a little bit too hot, but maybe we'll put a little dab more onto there. The rest of them seem okay, but let's just put a little bit more onto that one. We'll just give it a little dab of it. Just because I felt like that one might have overheated if it didn't have a little bit more on there. Next part is, well, that's what we're working with, at least in terms of the thermal paste. I don't know if it's too much. I don't know if it's too little, but it's kind of hard to judge on these as well because you're never really going to get equal amounts of thermal paste. That's probably why in a machine manufactured world, there's exactly the right amount of thermal paste on each one. But when you're repasting it, it's kind of just a guesswork on each one, trying to get them all equal. And if it doesn't work, then we can always take it apart and redo it. So obviously, I would like to see Avalon kind of come out with some better firmware for this. I know that they started an X community, which I think I joined, and there was a lot of comments in there talking about trying to get better firmware for this so we could actually overclock, underclock, set the temperature that we wanted it at, stuff like that. But now I guess the only thing we need to do is put this heatsink back on, put the screws back in, and then away we go. We'll give it a whirl. Even though we're not technically using it, we're just going to run it up and see if it actually starts up first, and then we're going to see what hash rates we get. I'm not expecting any different hash rates. I'm just hoping that it works, and we run it for maybe a day or two. Even though it's inefficient and we've taken it off of the whole rig, we just run it for a day or two to make sure that it actually works. So let's get this put back on and then we'll start it up. Okay, so now we've got it all back and packaged into there. We can actually plug it in. So okay, so it is plugged in and it's starting up, so that's always good. The fans seem to be blowing as well, which is always a good sign. So we'll kind of see what it throws out in terms of the hash rate straight away. We are on low mode, so I don't expect it to be any much higher than that. But if we're looking in there, that's 38 watts, so it's just running up the low mode, and it should give a terahash figure soon, hopefully. And I'll kind of judge the heat coming out of it, because there is an internal heat sensor on the chips, so I think that's what mainly it's running off. And yeah, we should be back in business, but as I said, we are going to let it run for a little bit. Maybe we'll come back when it's steadied out in terms of the hash rate and the wattage. So after leaving it for quite a while, it just span up to the same terahash that it normally sits at, which is 3.34, and the watts is 61 watts. So I didn't expect much of a difference, or any difference realistically. One thing is, it did take quite a while to spin up, around 45 minutes to actually get to this terahash. Maybe it was trying to configure some sort of the heat element in there and trying to determine the best overclock or frequency settings for the chip to produce a certain heat. As I said, that's kind of our video. At least it works and we know that it's going to power back on. So if you enjoyed, or if you have any questions about the Avalon Nano, please leave them in the comments below. Anything you want to see about it or anything you want to know about it, leave them below. Make sure you like the video and subscribe for more content like this.